Hey, Enrique.
Oh, hi, Isaiah. Funny seeing you here.
Come on in.
Remind me, where are we again?
Of course, we are in the Auburn Science and Engineering Center here at the University of Akron. This is my advisor, Dr. Tan's research lab.
Oh, okay. What are you studying?
I'm actually a PhD student in the mechanical engineering department, but actually most of my research focuses on aerospace.
Describe engineering in 3 to 5 words.
Innovative, reasoning, challenging, rewarding.
What made you decide to become an engineer?
Ever since I can remember, I love solving problems, but I also wanted to know why things happened the way they did. Engineering and research allows me to do both.
You can engineer one thing with 0 limitations. What are you making?
That's easy, an Iron Man suit.
Back to the real world. What would someone be surprised to know that you do for fun?
Aside from being a huge sport and fitness guy, I love traveling and seeing new places. But I especially love trying the local foods of the places that I travel to.
When you tell people that you're getting your PhD, what's their typical response?
Usually pretty surprised.
What's that do?
Yes, this is our impact testing machine. So essentially, it allows us to understand how resistant a material is to impact. Will the material withstand the collision or will it become damaged? This is essentially what we're trying to find out.
You can sit down with any mathematician from any decade. Who would it be?
Probably Isaac Newton. I heard his name in almost all my undergraduate courses. I feel like I have a few questions for him.
You mentioned research. What's yours about?
I study the nonlinear behavior of advanced composite structures under extreme environments using various analytical, numerical, and experimental techniques, ranging from artificial intelligence to even biomimicry.
Come again?
So I find inspiration in biological systems to design better materials, and then instead of running expensive experiments, I implement machine learning algorithms, which learns how the material will behave. And this essentially gives me a roadmap to designing new and better materials. And all I need to do is follow the map.
Any major accomplishments with those findings?
Yes, I was recently awarded an early career attendee fellowship for the 25th International Congress of Theoretical and Applied Mechanics.
What exactly is the Congress of Theoretical and Applied Mechanics?
So this is a conference where prominent speakers from around the world come and present their work in the field of mechanics. Now, mechanics is really just the study and the relationship of force, motion, and mass. So it's very broad.
On a scale of 1 to 10, how prestigious is that in the engineering world?
I would probably say an 8 or a 9. I've actually heard some people refer to it as the Olympic Games of mechanics.
What obstacle specifically was the most pervasive when applying for the fellowship?
So the fellowship is actually supported by the National Science Foundation, and applicants are selected by a committee that consists of world-renowned speakers and leaders in the fields of mechanics. So aside from being selected just based on your accomplishments, you're also selected based on your potential to be a leader in the field of mechanics.
What personal responsibility comes with the fellowship?
Aside from just attending the Congress, I will also have the opportunity to interact and network with mentors and leaders in the field of mechanics and stay involved in the mechanics community in the future.
What's one piece of advice you can give to an engineering student who wants to get their PhD like you?
Study something you're passionate about and never limit yourself. You won't regret it.
What's the coolest thing you can physically show us?
Probably this, which is a carbon fiber reinforced polymer. And this is actually what a lot of my research focuses on. I essentially try to find more efficient ways to integrate this into aerospace structures.
What's the coolest thing you can't physically show us?
So I recently published a paper that involved a gecko. And essentially what I did is I found inspiration from the geometrical features on their feet. And I applied these to adhesives so that I could design better adhesives for joining materials like carbon fiber to other materials like metal.
Here's the hard question. What's your dream job after getting your PhD?
If you would have asked me this 4 years ago, I probably would have given you a completely different answer. But I think that's what makes engineering and research so great. It allows us to discover what our true passions are. But since you asked, I want to work at a company where I can see the direct impact of my work and continue to be challenged, whether that's at NASA, for a company in industry, or even my own company. I guess we'll find out.
Awesome, Isaiah. Thank you for your time. Good luck on your journey.
Thanks, Enrique.